So we are doing objective discussion, no? Yes. Yeah. Which question? Pending? I think so. 59th question. 58th is over. No? Yes. See question number 59, Nana, all of you. Question number 59, what they are given? See there? If mass of microscopic particle as well as its speed are half, mass and speed, mass and speed both are half. Okay, if both are half, then de Broglie wavelength associated with the particle will be. So we know de Broglie wavelength lambda of a moving particle is lambda is equal to h upon momentum, that is nothing but mass into velocity. Now, for example, if mass is half and velocity is also half, because they are saying that mass of a microscopic particle as well as its speed are half. Yes, half of I have done. Then what will happen to new de Broglie wavelength? So new de Broglie wavelength lambda dash will become h upon mv by 4. Here it can be written as 4 into h by mv. Correct? H by mv is original de Broglie wavelength. Means lambda dash will become 4 times of lambda. Clear? Okay, na? Yeah. So it is C options increased by a factor more than 2. 4 is there. 4 is a more than 2. Okay. Check remaining options. Increased by a factor 2 exactly? No, it is wrong. Decreaser? No, it is increasing. Decreaser? Wrong. So your option should be 1. They have not given increase by factor of 4. They have given more than 4. Yes. More than 2. Means 4 is more than 2, you know? Yes. So option 1 is right answer. Got it, students? Okay, na? Next. Question number 59 is over. Let us go to question number 60. Yes. Here is a question. Question number 60. An electron and proton, this is a proton, electron and proton are accelerated to same potential. Then lambda of electron to lambda of proton what? Okay, we know that lambda is equal to h by momentum and it can be written as h by root 2m into kinetic energy, and kinetic energy can be written as root 2 into m into electron volt. Kinetic energy can be written as electron volt. Okay, so lambda will become h upon root 2m EV, charge of that particle into potential difference. Now they are saying that they are electron and proton, they are accelerated by same potential difference. Means V is same, V is constant. However, H is constant value, 2 is constant value. That means H is proportional to 1 by root of mass of the particle into charge of the particle. I'll write Q. Okay, E or Q, both are same. Okay, yeah. So what they are asking? So this is lambda. No? Yes. Lambda of electron by lambda of proton will become root of mass of proton into charge of proton divided by mass of electron into charge of electron, Q of electron under root. Clear? Yes, because inversely proportional, no, that's why. So it can be written as under root of mp into qp upon me into qe. Clear? Yes, we know that charge of proton and charge of electron are both are same. No? Yeah. Negative positive is different, so but magnitude wise both are same. So they'll cancel. Means lambda E by lambda P is equal to what? Root of MP by ME. So lambda of electron by lambda of proton is equal to under root of mass of proton by mass of electron. Inversely proportional, yes. So where it is? Mass of proton by mass of electron. Yes. Option 4 is right answer. Got it, students? Yeah, this type of questions you need to be careful. This type of questions for your board exam and competitive exam, they are asking frequently. Clear? Okay. Next, question number 61. See, question number 61, they have asked electron, proton and alpha particle have same kinetic energy. I think so. This type of question already discussed. All are having same kinetic energy. Their corresponding wavelength would have the following relation. We know lambda is equal to h upon root 2m kinetic energy. When kinetic energy is same, lambda is proportional to under root of mass. Means if mass is more, wavelength will be less. Okay? Yeah. See, we know what they are given. They are given electron, a proton, and alpha particle. So we know mass of alpha particle is greater than mass of proton is greater than what? Mass of electron. So if wavelength is more, mass is more, means wavelength will be less. Means wavelength of alpha is less than wavelength of proton is less than wavelength of electron. Yes, this should be the relation. Are you understanding? Because inversely proportional, no. That's why. Okay. So where is this option? Yeah, I think so. Option 1C, Nana. Option 1C are of you. Yes. Wavelength of electron. Reverse they are given. Wavelength of electron is greater than wavelength of proton is greater than wavelength of alpha particle. Yes. Option 1 is right answer. Remaining all are wrong. Got it, students? Be careful this type of questions. This type of questions you need to be careful. Clear? Okay. Next, 61 is over. Next to 62. See what they are given. What is the de Broglie wavelength of electron with kinetic energy of 120 electron volt? Okay. Kinetic energy given. How much given, right? 120 electron volt. Okay. And they are given H value, Planck's constant value given 6.63 into 10 to the power of minus 34 joule second given. And mass of electron also they have mentioned. How much it is? 9.11 into 10 to the power of minus 31 kg they have given. And charge of the electron also given. 1.6 into 10 to the power of minus 19 coulomb. All values we know. Okay. Yeah. Now what they're asking? De Broglie wavelength of electron. What they're asking? We know Hc momentum. Lambda is equal to h by momentum. No. Yes. We know lambda is equal to h by mv. H by mv. But we don't know. But kinetic energy given. No. So that's why it can be written as root 2 times of mass into kinetic energy we can write. Okay, so mass given, kinetic energy given, next h value given. So kinetic energy given in electron volt means we have to convert it into 120 into 1 electron. How much given? 1.6 into 10 to the power of minus 19 joules. This value you need to substitute here in the place of kinetic energy. Mass of electron given. So you do calculation, this total calculation, you will get the answer. Okay. Option 62. Option 112 picometer will get. Pico means 10 to the power of minus 12. This is one method. Another method we are having. We know kinetic energy of electron. Direct calculation is 12.27 angstrom upon under root of voltage. We know this formula directly. But voltage is not given. Even though kinetic energy given, no. Even though voltage is not given, kinetic energy is given here. Okay. Yeah. So that means we know that kinetic energy is equal to electron volt potential difference. Okay. So kinetic energy given 120 electron volt is equal to EV0. Then E cancel. So potential difference how much? 120 volts. Yes. Means this value we can substitute here. Means you'll get 12.27 under root of 120. In angstroms you will get the value. Okay. So root 120 value how much? Let us check in calculator. Root 120 under root of 120 we want to. Okay. Yes. So root of 120 is 10.94. Yes. Root 120 value is 10.954. This is the value. Okay, do this. So lambda of electron becomes 12.27 by 10.954 in angstroms. How much it is? 12.27. 12.27 divided by 10.954 comes out to be 1.12 angstroms. So 1.12 angstrom means 10 to the power of minus 10. So if you convert into 12, it will be 112 into 10 to the power of minus 12 meters. So 112 10 to the power of minus 12 is nothing but pico. So picometer we can write S. Exactly we have got C. Okay. Thing is, if you do with this method, if you do calculation becomes too length, too difficult. So if you remember, whenever electron is given, try to solve the problem with this method. If voltage, if you are unable to find, then you can go with this method only. If you are able to find a voltage like this, if you are able to find the voltage like this, then you prefer this method only, because it is somewhat easiest way to get the value. Are you getting, students? JEE students. Moreover, JEE students, you need to be careful this type of problems. Okay, have you applied? How many of you applied for JEE in first term? First phase, right? It came, no? Apply for that, and I will send you recent year all papers copies. I will send to your WhatsApp group. Today I will send. Try to practice all the questions. Concept wise, remember, don't remember the problem. What concept they are asking, that you need to digest. Okay, try to solve all the questions. I'll send that today. Okay, next question number 63, Nana. Yeah, 63 given. See, if lambda p and lambda e be the wavelength of protons and alpha particle, lambda alpha it is, of equal kinetic energy, then so kinetic energy of what they have, proton is equal to kinetic energy of alpha particle given. Okay, what they are asking, lambda p and lambda e, lambda alpha. Okay, so wavelength we know lambda is equal to h by root 2 m k. When kinetic energy is same, lambda is inversely proportional to under root of mass. Okay, that means lambda of proton is to lambda of alpha particle can be written as 1 by root of mass of proton is to 1 by root of mass of alpha particle. We know alpha particle is nothing but helium-24, means mass of alpha particle is 4 times of mass of proton. So it will be lambda of proton is to lambda of alpha particle is to, I am writing, or divided by you can take. Okay, divided by. Okay, so it will become divided by, means root of mass of alpha particle by mass of proton. So we know mass of alpha particle is 4 times of mass of proton divided by mass of proton. So root 4 means 2, means lambda p by lambda alpha is equal to 2 we are getting. Then lambda p becomes how much? Lambda p becomes 2 times of lambda of alpha. Yes, option 4 is right answer. Just the calculations, Nana. Only the thing here is we should know this formula, and what they are giving saying that we should not take into that equation because they will cancel. Are you getting clear, students? Yes, 63 is over. Next, let us go for next question. 63 over. Yes. Now previous year questions, Nana. See here. Previous year questions, these are. Okay, let us see them. A photocell employs photoelectric current to convert. Okay, photocell, what it will do, Nana? Photocell, what it will do? Simply, it will change the incident photon intensity into electrical energy, Nana. That's it. Okay. So it will, see, first option changes the frequency of light into changing the electric voltage. Wrong. Frequency gives you kinetic energy only, but electric current depends upon the number of charges. Number of charges depends upon the intensity of incident light. Okay, and intensity is independent of frequency, you know. Okay, yeah. Next option to see change in intensity of illumination into change in photoelectric current is option 2 correct answer. If intensity changes, number of photons incident on the metal surface changes. If number of photons incident on the metal surface changes, number of electrons ejecting out also changes. Electrons ejecting out is nothing but flow in a circuit, means electric current changes. Option 2 is perfect answer. You need to remember the concepts number. Option 3, changing the intensity of illumination into changing the work function. Work function is always same, depends upon the nature of the material. Changing the work function they are saying, so wrong it is. Next, change in frequency of light into change in the electric current. Wrong. Frequency does not depend upon the electric current. Only intensity depends upon the electric current. Option 2 is perfect answer for this. Okay. Next, question number 2. When photons of energy h nu falls on aluminum plate of work function E naught, photo electrons of maximum kinetic energy K are ejected. Okay. If the frequency of radiation is doubled, see, frequency of radiation is doubled, they are giving. The maximum kinetic energy of ejected photoelectrons will be, yes, important questions for JEE students as well as for NEET students. Very important question. If you want, you can refer your previous year papers. You can see this type of JEE questions. Okay, yeah. So let us see. What they are doing is, what they are saying that, so on a metal surface, this, let us imagine this is a metal surface. On this metal surface, energy is falling. Okay, and this metal surface is having work function, that is E naught, they are saying. Okay, and now the energy of photons which are falling is equal to hf, they are given, or h nu they are given. Okay, energy of photons they are falling is h nu, they are given. Clear? Okay. Now, due to that, electrons will eject out, and these electrons, they will move with some kinetic energy. Okay, and kinetic energy, the electrons, they will move due to this energy is K. Now what they are doing? Same metal surface they are not changing. Whereas this intensity of energy of light ray, their frequency is double, they are doing. This frequency, see, frequency of radiation is double. This is double, means this frequency they are making double. So work function, it will be same only. Due to that, electrons will eject out. This kinetic energy of electrons, what they are asking? Question understood? Okay. Now, as we know that kinetic energy depends upon the frequency, means frequency changes means kinetic energy also changes. How it changes, we need to find. Okay, yeah. So according to Einstein photoelectric equation, we know kinetic energy E is equal to energy of incident radiation minus work function. This is according to Einstein photoelectric equation. Okay, now first condition, kinetic energy is K given, and energy of incident radiation is h nu given, minus work function is E naught given. This first condition, K equation number 1 take. Now second condition, kinetic energy we need to find will be equal to h into frequency is double, means 2h nu. Okay, frequency is double, minus work function is remain same. Are you understanding what I am doing there? Yeah. So this equation can be read like this: h nu is equal to this. This will become 2h nu minus E naught. Correct? Yes. So 2h nu I am writing h nu plus h nu minus E naught. Can we write? Yes, we can write. Okay. What is h nu plus E naught is what, Nana? Is kinetic energy K given from equation 1, means K dash become this h nu plus initial kinetic energy. Yeah, this is your final kinetic energy. Yeah, where it is? K plus h nu is option 4. Got it, students? How to do this type of problems? Okay. Clear? No. Important questions. See, so many questions will repeat like this now in this only. See, you can check them. So second option is over. Second question is over. Next, question number 3. We'll go to question number 3. Question number 3. What they are given? See, the momentum of photon of energy 1 mega electron volt is, okay. Energy is given. How much, Nana? 1 mega electron volt. Okay. This is the energy of the photon they are given. Then what is the momentum of this photon they are asking? Till now, whatever we have done, we have written wave according to dW, lambda is equal to h by p. So momentum can be written as p is equal to h by lambda. So when you know lambda, we can find momentum. Okay, good. But they have not given a wavelength, they are given energy. Then what to do? What to do? See, we know that energy E, according to Einstein equation, energy is equal to mc square. No? Yes. Can we write this energy E is equal to mc into C? Can we write? Yes, we can write. Clear? Yeah. So energy is equal to this m into C because it is a photon they are saying. See photon. See always photons moves with the speed of light. So when a photon having mass m and moving with the speed of light, then its momentum is mc. Means we can write P into C. Then momentum P can be written as E by C. Correct? Yeah. So we can get momentum from this equation. Yeah. But energy how much given? 1 mega electron volt given. See, 1 mega electron volt. Whereas C we know it is 3 into 10 to the power of 8 meter per second. Meter per second. See, C value I am writing. 3 into 10 to the power of 8 meter per second is the unit. Whereas here electron volt is not a SI unit. So let us convert into SI unit. 1 mega means how much now? Mega means 10 to the power of 6. Kilo means 3. Mega means 6. Into electron volt is 1.6 into 10 to the power of minus 19 joules. Means it is 1.6 into 10 to the power of 1.6 into 10 to the power of it will become 1.6 into 10 to the power of minus 19 plus 6 is minus 13. Okay, joules. Yes, this is energy. So right, 1.6 into 10 to the power of minus 13 joules. Yeah, so this is SI unit, this is SI unit. Okay, we can cancel them. Okay, 1.6 divided by 3 means how much, Nana? 1.6 divided by 3. 3 ones are 3. 3 0 point means 16. 3 5s are 15. Yes, 1 is there. Because of point, it will become 3 3. Clear? Yes, means 0 0.533 into 10 to the power of minus 13 going to minus 8 going to upside, it will become minus 8. Minus 13 minus 8 how much, Nana? Minus how much? Minus 13 plus 8 is how much? 21. Correct? Yes. Okay. Then can we write this 0.5 as 5 into 10 to the power of minus 22? Yes, we can write. Yes. C option is there. Option 4. Option 4 is right answer. What it? New thing is you need to be perfect with your calculations. Students, okay, Anna? Clear? Next. Question number 4. What they given? In photoelectric effect, electrons are ejected from metals if the incident light has certain minimum frequency. Frequency should be, for photoelectric effect to occur, frequency should be minimum and whereas wavelength should be maximum. This is the condition because energy of incident radiation E can be written as HF or HC by lambda. Clear? Minimum frequency should be required. More than that only we want. Otherwise photoelectric effect doesn't occur. So that's why this is equation. This is, we can say it is a law of photoelectric effect. You know this. Clear? Okay. Next question number 5. Question number 5, see Nana, what they are given? Very important concept for JEE students and NEET students. Be careful, you may get in this phase first. For those who have applied for the JEE, you may get this type of questions. See what they have asked. A 5 watt is that? Watt is nothing but unit of power. Okay. A 5 watt source emit monochromatic light of wavelength 5000 angstrom. Okay. Means let us imagine here there is a bulb. Here there is a bulb is there. Okay. And this bulb emit light. No, yes. This bulb emit light and this bulb power is given 5 watt given. Okay. So what is the wavelength of this light is coming like this? What is the wavelength of this light given? 5000 angstrom given. Okay. Now when placed 0.5 meters away. So if this light is placed 0.5 meters here, let us imagine from here, from this point 0.5 meters away it is placed. It liberates photoelectrons from a photosensitive metallic surface. Okay, so let us imagine this is one metal surface. Let us imagine, Anna. This is one metal surface. It is placed like this. Okay, now when this light falls on this, photoelectrons will emit out, will eject out. Yes, photoelectric effect will occur. Clear? Yeah. So when this bulb is placed at 0.5 meters away. Clear? Okay. Now, when the source is moved to 1 meter distance, now this source you move to 1 meter distance. Here, 1 meter distance you keep this source. Light bulb you keep here. Now also light falls and electrons will eject out. Now, the number of photoelectrons ejecting, what happened? What happened to the number of photoelectrons? How many number of photoelectrons will eject out? This is the question. Clear? I hope you understand the question clearly. Once if you understand the question, then it will be easy to solve. Understanding is important, Nana, here. Right? Eraser. Now, before doing this, I need to clear one concept. Already I have explained while discussing this chapter. Again, see, we know power. Power means what, Nana? Power is nothing but energy upon time. Yes or no? Yes, power is equal to work by time or energy upon time. Clear? Yes. So this is the power due to one electron, one photon. If let us imagine from this n number of photons are ejecting out, then total power P will become n into energy of each photon upon time. We can write. Are you understanding? Clear? Okay. Yes. Now they are giving distance. They have given the distance 0.5 meters and 1 meter about this. Okay. So if they ask what is the energy, means energy we know E is equal to hc by lambda. Lambda given. We can write 12,400 upon lambda in angstrom. We can write. We'll get the energy of each photon, and we can find number of electrons also. Clear? And one more formula is there. Power P is equal to intensity of incident radiation upon area of cross section. Means, see how I am trying to explain you this. See, listen carefully. Listen, your understanding is very important. This formula, remember, okay? Just clarity on. See, here there is a bulb. Let us imagine here there is a bulb. Okay, it is emitting radiation. How it will emit? It will emit radiation in all directions. No? Yes. Now, at a distance of, let us imagine R. Now, spherically on its surface, light bulb falls. Clear? Yes. So, power of this light can be written as intensity of incident radiation upon area of cross section. And this area of cross section is R, means spherical surface. So power can be written as intensity of incident radiation upon pi r square. Spherical surface, no? 4 pi r square. Spherical surface. Means power is inversely proportional to 1 by r square. Means 1 by distance. Power is inversely proportional to distance. Clear? And just now I have given that this power is nothing but number of photons into energy upon time. Means power is directly proportional to number of photons. That means number of photons is inversely proportional to 1 by r square. We can get this relation to find this answer. New relation we have got. Means now, for example, n1 by n2 you want. You can write r2 square by r1 square. Are you understanding? R2 is 1 meter, 1 square. R1 is 0.5 square, 0.5 square. Clear? That means N1 by N2 becomes 1 divided by 0.5 means 1 by 2. We can write, I'll write 1 by 2 square. Means N1 by N2 become 1 by 1 by 4 means n1 by n2 become 4. Now you want n2. Second number of photons you want to know. N2 cross multiply them. You get n1 by 4. N1 is first number of photons. So what happened to the number of photons when we move away? When we move away, this distance if we increase, number of photons decreases by how much? 4 times for this. So reduce by a factor of 4. Option 2 is right answer. Students, did you understand this clearly? Do you understand, Nana? Clear? I hope you are understanding clearly what I am giving solutions. Clear? Yeah, important, Nana. That's why. Okay, next. Question number 5 is over. Next question number 6. Yeah. So question number 6, what they have given? See once. Question number 6 is a monochromatic light of frequency given 6 into 10 to the power of 14 hertz is produced by laser. One laser beam is there which is producing light of frequency this much. The power emitted is, the power of this emitted light is this much. Then number of photons emitted on the average by the source is what? So just now I have given that, just now